the lead code problem, longest common subsequence. So in this problem, you're given two strings and you need to return the length of the longest common subsequence. So what is a subsequence? Here's an example which will help to understand. So given the words A's and A, B, C, D, the longest between them is 3 letters since the characters A, C, and E are matching. Same thing with this ABC, all 3 are matching. So here's the one where none of the characters are matching, and so we return 0. So I think a few things when you have to understand the subsequence means that the order is important. So it's a case where, so imagine instead of A, C, E, and here we had A, E, and C. So although the characters are present in the two strings, since they're not in the correct order, the maximum will be returned as true. So yeah, so that's how. So this problem I would say is one of the most common problems involved with dynamic programming. And I think back in college when I was studying it, this was a problem they used for teaching me. So I've seen this problem being asked for Google coding interview questions, and a lot of people, I think when they try jumping into the problem, they use recursion. So for this, I'll try solving both recursion and dynamic programming and explain the difference between the two. So recursion, the way we can solve it is we can just have recursively keep checking each character in the string and doing a comparison, and then determining if the characters match, we add 1. If not, we keep moving to the next character. So to do that, let me first create that method. So it'll be like public int. Let's copy this. So here we'll take 4 values. We'll say string text1, string text2, and then we'll take 2 integer values. So this will help us to keep track of which is the current index. So int index1 and int index2. And here, so all recursive functions require a base case and a recursive case. So the base case would be we have reached all the way, the index has reached all the way to the end of the string. So if that has happened, there's nothing more to process. So we return 0. So let's just add that if index1 So that's the base case. Other case is that if both the characters at the index are matching, when that happens, what we need to do is we need to add 1 because since they're matching, and then we need to move to the next characters. So else if if both are equal, we say return 1 because they're matching, and the next thing I do is move to the next characters in the index. So we just say, I'll just copy this since I'm lazy. So we're just moving to the next index value. Else, so we have now 2 options. So we can move either the first or the second character, second index. So we don't know which ones are matching. So what we'll do is we have to return the maximum of the value returned by the 2 of those recursive calls. So let's just add that else return so here we just say text1, text2, and we increment only the first index. So now we are just we are going to move to the next character, the first string, and see if it matches. And the second we just leave it unchanged. So we just compare this. So here's an example. So just going to recap, let's just call this method. So we just say return longest common sequence. And since we are starting, you just say it's 0, 0. So yeah, just recap. What we're going to do is recursively, we are going to keep track of what the current index is, and we keep comparing the characters. If the characters match, we add 1, else we move to the next character in the string, and we keep doing it until we reach all the way to the end. So yeah, let's try running the solution. So yeah, the use cases are passed, but this is kind of expected because you hear the input, as you see, is pretty small. When I try submitting it, it's going to fail. And yeah, the reason it's going to fail is because of the time complexity of this solution. So what happens is that at each character, we have to consider, it can either include the character or not include the character. So, it branches off into two different recursive cases, and we keep doing it for each and every characters. So the runtime time complexity is exponential. It's 2 to the power of n. So you can see, right, even a string which is of size, I think maybe 12 characters, even for that, it's failing. So any problem where the solution seems to be an exponential one, usually in interviews questions, when you ask that, you should identify it as a dynamic programming. So advantage of dynamic programming is it helps you to break down the problem. What you need to do is visualize that given this 2, what if there's only one character? For example, here, let me just add this. So here, imagine both the strings are empty, so the answer should be 0 because there's nothing to compare. Now imagine one string, the string 1 is empty and the string 2 is ACE. Here again, since there's nothing to compare, it always be 0. Same thing, if string 2 is is the ABCDE and string 1 is an empty string, there's nothing to compare. So we just say 0. Sorry, I'm having some problem with my mouse, but hopefully you can understand the 0. So yeah, so here now, this is the problem. Now you have to consider there's just one character A, and you're comparing with ACE. So only the characters A and A are matching, so we say 1. The A, C and A, only the A is matching, so we say 1. So A and AC, only one character is matching. So if you have broken the problem into this, where we have this one character A and the other string has ACE, we can say the maximum value that can be returned is 1. Now given B, so there's no match. So AB and ACE, the maximum will always be just 1. Again, breaking down ABC and ACE. So ABC and A, there's only one thing matching. So here we just say 1. But now ABC and AC, 2 characters are matching. So we say 2, and here also will be 2. So I think from here we can understand what the algorithm should be. So whenever a character is matching, the value will be 1 plus the value diagonally opposite to it. So here we have to add AC. So what you have to do was, since the characters are matching, we have to just ask yourself, if it was just AB and A, what is the maximum value? Once you added C to it and AC to it, we knew that one more character was matching. So the algorithm would be like, if characters are matching, the value will be equal to 1 plus the value diagonally opposite to the table, and if not, it will be the maximum of that row or column. So yeah, we can continue filling it, and you can see what the value at the end of the table, that's the value that we need to return. So yeah, let's try using dynamic programming to solve this problem. So let's take all this off. So for this problem, we just need to create a table similar to this. So the size of this table will be equal to the length of the 2 characters plus 1, because we are adding an extra row just to keep track of the zeros, I think 0th row. So int result. So yeah, this is the result array that you're building. By default, integer values are initialized to 0. So we don't need to initialize the first row and first column. So here the 0th row, 0th column has already been initialized for us. So next thing we need to do is we need to create 2 for loops to fill the rest of the table. So let me just add that. see the result. This makes it easier to understand. So now we'll just discuss what we did, which is that if the two characters are matching, so if so result I minus j is like we discussed 1 plus yeah, just to clarify, what I've done is that essentially we're trying to fill this 2D table that we had, and for the reason we are making the value of it 1 greater than the length is because we also want to consider the case where it's completely empty, and that helps us to fill the table. So whenever that happens, what we say is that if the characters are matching, the value will be equal to 1 plus the value of the row, the cell diagonally opposite to it. So it's going to be 1 plus the diagonal cell. Similarly here, 1 plus the cell diagonally opposite to it. Else it's just the max of either the previous row or the previous column. So yeah, we keep doing it until we reach all the way to the end of that 2D table, and we just return the value at the last cell. So that's the value we're going to return. So we just say return result So yeah, let's try running the solution. Oh, I think I made a text one. And I believe that's the only place I made. Oh, I think here I just had to say, since it's a string, I just need to call a method. So yeah, let's try running it again. All right, all the use cases are passed. We'll try submitting it. So yeah, for this solution, the time complexity will be O of n into m, where n is the length of the first string and m is the length of the second string. So this is because we're just creating a 2D array of size n into m, and we're just traversing down it. Same thing, the space complexity of this will also be of O of n into m, because also here we are creating a 2D array of size n into m, and we use it to traverse the two strings, decide which is common, and return the value.